To receive the greatest benefit from this film, have your CD3A system ready to assemble. You will not need any tools, just the components. In addition, have your resin and solvent. The solvent should be acetone, methyl ethyl ketone, or other petroleum-free solvent. You will need a compressed air supply of 80 to 120 pounds per square inch, no more than 120. The volume is small. Only 1 to 2 CFM will be sufficient. It is important to understand that this film does not replace the operator's manual. 2 operator's manuals are furnished with the machine. There is much material that is covered in the operator's manual that is not discussed here. This information is important, pertaining to ratio checks to maintain accuracy, maintenance, troubleshooting, and safety. The operator should not go into the field without being thoroughly familiar with the manual. Most of the features discussed in the film are common to the low viscosity injection dispenser as well as the gel system. Those characteristics which are unique to the gel capability are discussed in the manual furnished with the conversion. We are going to back into the demonstration by starting with the cleanup. This tank is what we call the Purge Tank. It is a 2-gallon pressure vessel. At this time, we want to put about 1/2 gallon, no more than that, 1/2 gallon of solvent into the tank. The lid is removed by lifting the bale and depressing the lid. Pour in the solvent, reset the lid, and snap the bale. To empty this vessel, or to remove the lid, it must be vented because the pressure will hold the lid in place. Now we wish to pressurize the tank. To do this, we need our air supply. This lead with the chrome connector on one end and the threaded fitting on the other is our air inlet supply. This end of the fitting should adapt to your air supply. Connect the air supply with this coupler to energize the tank. The reason we did this is that in the event we lose our air supply during the course of the day, we still have enough energy stored in the tank that we can conduct our cleanup. If you fill the tank with solvent, you have very little energy stored by way of compressed air in a much smaller space. Now we set our purge tank aside for later. Charge the pressure tanks. The lids are identical to that on the purge tank. The volume of resin you put in these tanks does not affect the accuracy or performance of the system. Replace the lids. The 2 black lines from these tanks are the material lines supplying resin to the dispenser. Connect these lines. The fittings are dissimilar. If they fit, they are correct. Next, we need to connect our air lines. The air supply enters this manifold fitting on the base resin tank. The base resin tank is pressurized through the vertical stem, which is in fact a check valve, so that if the tank tips over, resin is not spilled into the air supply line, contaminating the catalyst tank or the dispensing cabinet itself. From this outlet, we connect the segment of tubing without fittings. This type of connection is common throughout the system. Press it in, it grips. To remove it, draw back on the collar, and it disconnects. This line is going to pressurize the catalyst tank. There is also a check valve component to this connector to prevent the catalyst resin from spilling back into the air supply. And finally, we supply air to the cabinet using the length of tubing without a fitting on one end and with a chrome coupler on the other. This coupler connects to the cabinet adjacent to the air filter, and the other end is pressed to connect at the manifold. At the outlet, or downstream end of the system, we will now connect the tubing about 3 meters in length without a fitting on one end and with a shut-off cock on the other. This is your dispense lead. Press to connect the fitting at the manifold. The connector at the outlet end connects to the nozzles. The system is now ready to operate. Make certain that the on-off switch is off. connect the air supply. Turn the air regulator counterclockwise until the pressure gauge is at 0. Reset the counter by pressing the reset button. The counter keeps you posted on resin consumption. At a 2-to-1 ratio, for example, there are approximately 100 strokes to the gallon. Now turn the switch on. The system is operating. It is not dispensing because there is no air from the regulator. At a 2-to-1 ratio, the dispense pressure will be approximately 6 times the pressure that is introduced to the air cylinder internally at this regulator. Before starting, be certain that the shut-off cock on the downstream line is closed. Now gradually introduce air pressure to the system. Run the pressure up to 30 psi, which will be about 180 pounds per square inch. The system is operating even though there is no flow because it is simply compressing air in the lines. Observe it for a moment. Make certain all the fittings are tight. Now open the shut-off cock to dispense resin. When the shut-off valve is closed, the system will hover, constantly maintaining that pressure. You simply move your connector port to port, or you may manifold from the cabinet or at the end of the line. There are a couple of problems that can be inadvertently introduced into the system. If the unit is operated at an insufficient air pressure, it will become disoriented. This can occur if the system is connected prior to starting the air compressor, allowing the air to gradually build and marginally operate the unit at the lower pressures. The same thing will happen should the air supply fail. The unit will struggle to operate at the falling pressure. The same symptom can be introduced by snapping the on-off switch back and forth very rapidly, allowing sufficient time for a sequence of signals to start, but not sufficient time for their completion. In all of these instances, air gets trapped in one of the pilot lines component to the air controls. This symptom can be recognized by the ball valve orientation. Normally, the ball valves on the supply side and the dispense side are in dissimilar positions. That is, one side is open and the other is closed. When the screws securing the coupler between the ball valve actuator and the ball valve are perpendicular to your vision, the valves are closed. When they are parallel to your vision, the ball valves are open. When the problem occurs, all of the ball valves go to the closed position. I will now introduce the problem by rapidly operating the switch. To correct the problem, disconnect the air supply at the cabinet and thoroughly vent the air filter. Reconnect the air supply, and as you see, the ball valves became reoriented. This is one of the most common problems which we have in the field. There is one other problem which is introduced during the course of the cleanup. The cleanup sequence must be exact. Do not deviate from what you see here. The first thing you must do is throw the switch off. Do not be in a hurry and disconnect your air supply prior to turning the switch off. The switch is air actuated, and it will be dead if the air is disconnected first. After turning the switch off, we are ready to use the purge tank. Be dead certain, and this is important, that the three-way ball valve component to the purge tank is in the horizontal or closed position. In addition, be certain to vent any entrapped air from the purge lines component to the tank. This is done by pressing the nipple against the edge of the tank. After both leads are vented, connect them to the purge leads on the supply side of the tank. Now open the shutoff cock at the downstream end of your dispense line and rotate the ball valve handle to the vertical position with the arrow pointing up. Air is now being forced through the purge lines, across the horizontal lines in the top of the cabinet, and downstream through the mixing head. With your air supply connected to the purge tank, continue to blow the lines out until there is no slobber or drool at the outlet. This will take about 1 minute. Then quickly turn the ball valve handle 180 degrees and return it promptly so as to introduce solvent bursts into the airline. The burst should be as small as possible so that the velocity of the air is not reduced. The solvent is functioning as an abrasive. The greater the velocity, the more effective the solvent. Normally, 6 or 8 cycles will be sufficient. Then rotate the valve to the solvent position and close off the shut-off cock. Then open and close the shut-off cock under the solvent flow in order to clean it. Your shutdown is now complete. Simply disconnect the purge tank. It can be left completely assembled until the next day. Resin can be left in the balance of the system for some duration without detriment. There is a great deal not said in this film. Go to the operator's manual for clarification. The clarifications you require are no doubt there. Good luck, and let us know how we can help you.